So we're back. I left you on the cliffhanger of how many mathematicians does it take to turn a light bulb. The truth is, I know no jokes whatsoever. I have no idea what a good math joke would be. So um, now we're going to do some of your homework problems. Maybe my assignment for tomorrow will to find a good math joke. I'll see if I can figure one out for you. Okay, so these are problems that you're going to be asked to solve. Find all the solutions of cosine x equals negative 0.564. So if we have this, cosine x equals negative 0.564, we want to find all the solutions. You'll notice that in the break, I put up all the solutions. For cosine, all the solutions are going to be the initial angle that we find using the Arcos function plus 2k pi and minus that angle plus 2k pi. Once again, for this calculator, I have no idea what this is, so I'm going to put it in. So we're going to punch this in, negative 0.564. I'm in degree mode right now. I hit second, hit cosine, which is our Arcos function, and this says this is 124.3328 degrees. Okay, so this is, so x is approximately 124.332807. Okay, so where would I abbreviate this in general? Maybe to the second place, 124.33. 2 is less than 5, rest drops off. I'm going to go into radians now because you're really supposed to do this in radians, and probably you're always going to do that. However, I just wanted to get a feel for where this was. To me it really helps to have some kind of picture. 120 some odd degrees is probably there. And then we're going to do the negative of that, right? The negative plus 2k pi. Where's the negative of 120? Well, that's probably, I don't know, somewhere around there. Something like that. Let's go into radians, though. Let's see, 0.564 negative. I want to be in radians, Arcos. So this, okay, so this says x is equal to 2.17 radians, okay? And what did I do? I just did this. Technically, I did hit the Arcos of cosine x equals the Arcos of whatever this was, which is minus 0.564. And my calculator spit out that this implied that x is equal to 2.17, and this is radians, and usually I don't write radians, but I just wanted to make it really clear where we are. So now what are the solutions? By this, the solutions are going to be u, which is, in this case is 2.17, 2.17 plus 2k pi, and then minus 2.17 plus 2k pi. And where k is an integer, and I keep writing this down, and you're probably going, oh my god, we know that, quit writing that down. However, if you don't and you're taking an exam, it's quite possible they'll nick you for a point or something. Okay, let's just keep working some of these problems. Let's see if I can find anything good here. Oh, okay, sure. A problem, okay, so this problem would be considered too easy to put on a test. I mean, it's just a matter of punching a button, right? Hitting your Arcos button. Something you're more likely to have to toil with is 2 cosine x over 2 equals the square root of 2. 2 times cosine x over 2 equals the square root of 2. Thanks. Okay, so the first thing is here, can I just hit Arcos square root of 2? Well, no, there is no Arcos. If you did this in your calculator, it would say error. Why? Because square root of 2 is bigger than 1. There can't be, this function only maps from negative 1 to 1 back to these angles. This doesn't even make any sense. So the first thing I need to do is get rid of the junk in front of this. Let's divide out. And so now we have this. Cosine of x over 2 is equal to the square root of 2 over 2. I recognize this. This is 1 over the square root of 2 in modern speak. And I already know, so what I'm going to do is I'm going to do my deal. I'm going to take the Arcos of cosine x over 2 So I'm taking the arcos of both sides. This undoes this. The x over 2 drops out. Arcos of 1 over the square root of 2. So we have this. X over 2 is equal to arcos 1 over the square root of 2. That's pi over 4. It's 45 degrees. It's one of those ones we hope you know, that cosine of 45 degrees is 1 over the square root of 2. So this is going to be, the solutions here are going to be 1 pi over 4 plus 2k pi. And remember what I was saying before you do any multiplying or dividing, just whatever this was, these are the solutions to this whole thing, and then we're going to do some fixing up. Also, this was cosine, so the negative of these x over 2 has to equal negative pi over 4 plus 2k pi. Now, it's safe. I'm going to multiply everything by 2. So multiplying by 2 on this side, I get x, gets rid of the 2, equals pi over 2 plus 4k pi. And on this one, I have x is equal to minus pi over 2 plus 4k pi. So here are the two solutions. Are they actually different? And what do I mean by that? Are these in fact different branches? Well, how do we find out? When k is 0, this is pi over 2, and this is negative pi over 2. Is there any way to make this turn into negative pi over 2 just by having a negative k? And no, I don't see it. So these are in fact different. Is it obvious that they're different? I think so. I'm not sure. I think it's just important to analyze your answer and see what you've got. Okay. So let's take another look-see here. Oh, how about this one? So I can't do anything too complicated because we're running out of time here. Master producer, what do we got left? 2 minutes? Okay. Oh boy, oh boy, oh boy, oh boy. Well, we haven't done one with tangent. So let's do tangent x equals negative square root of 3. So tangent x equals a negative square root of 3. And what was for tangent? Remember, if u is a solution, then it's u plus k pi. Negative square root of 3. So here's my 3 square root, hit the negative, second, and tangent. This says minus 60 degrees. Okay, so the arctangent of tangent x, this just spits out the x, is equal to the arctangent of negative square root of 3, and this spits out 60 degrees. Actually, it spits out negative 60 degrees. Okay, so what is negative 60 degrees? This is negative pi over 3. First thing you should be thinking, does this make any sense? But yeah, it does. Remember that tangent is defined from negative pi over 2 to pi over 2. You'll notice that negative pi over 2 and pi over 2 are not included in this. So the solutions are going to be negative pi over 3 plus k pi. Should we write this in terms of positive radians? Well, if we do that, what is this? Well, if we go down, so if we look at the circle, and I'm running out of time, here is negative pi over 3. If I want to write this in positives, where is this? It's right here, so it's this plus 2 pi. So negative pi over 3 plus 6 pi over 3. This is 5 pi over 3. And we've done this a couple ones. 5 pi over 3 plus k pi. These are the same answer, right? I'm 100% okay with this. You will find some instructors who insist on this. So that concludes this particular lecture series. I'll see you tomorrow.